Thank you. You'll have to forgive me if I'm not at the top of my game this morning. I just got off a 15-hour flight from Seoul, Korea, and I'm giving a speech in a sauna. So forgive me. But as Amanda mentioned, I have spent the majority of my career working at the Linux Foundation. You know, really my claim to fame is that I'm Linus Torvalds' boss, who wrote, both Linux and Git, literally two roles in one in software, the most important software projects in the world. Linus doesn't really listen to anything I have to say. In fact, it's more accurate to say I really work for Linus and for the maintainers who co-create the software that the world depends on. So I really appreciate an opportunity to talk to you all today about an enormous problem that we face securing our technology infrastructure and really our collective global security. And that problem is around supply chain security. To fix this, we must all work together. And today I'm going to tell you how we can work together as a community to fix this problem. And a bit about how we're doing that with the Open Source Security Foundation and in a public-private partnership with governments around the world. I should probably first just introduce a little bit about the Linux Foundation before I dive in. As an aside, my wife, who's a successful technology executive and Harvard MBA, really had an obvious look of disappointment when I first met her on our first blind date. When I told her I worked at a nonprofit. Like Linus, she also doesn't listen to me. But after a while, I showed her that open source and the projects at the Linux Foundation can have an impact in a way a normal for-profit company cannot. Today, the foundation is home to some of the most critical software in the world. Linux, which runs the vast majority of the world's computing systems. Projects such as Kubernetes, which has redefined the way we build, manage, and deploy applications on the cloud. Node.js, the world's largest server-side JavaScript framework, which is used to build most of the websites and mobile applications that you use every single day. Things like PyTorch, a recent new project in the area of artificial intelligence, which is really becoming a de facto platform for building ML models and deploying them in an easy way. But after I started working at the Linux Foundation, what I really came to realize is that we're really the supporting cast, that the Linux Foundation is really in the business of facilitating open collaboration. Our 350 employees today work in supporting these projects. We have offices in Japan, Hong Kong, here in London, and also have just recently created an entity in the EU. The work we do is to facilitate the work of over 780,000 developers that work in our projects every single day. We host 30,000 video conferences every year, gather 100,000 developers across over 150 events worldwide. We facilitate the intellectual property that is worth billions to mankind, and we really work to train developers, of which every year over 1 million developers participate in our training. We really provide this neutral home for collaborative innovation and try and facilitate that both across critical components of technology, but also in specific industry sectors. In media, we work with the Academy of Motion Pictures, Arts and Science. All of the film studios got together and decided they wanted to open source the software that they use to create the special effects in the movies that you love, Star Wars and all the Marvel movies. In transportation, our automotive-grade Linux initiative is inside tens of millions of production automobiles today, providing that digital cockpit experience in your automobile. In the energy sector, we work with grid operators here in Europe and across Asia to open source the code that's used to distribute power, reducing waste in these distribution systems and helping with climate change. And in communications, our Linux Foundation networking project powers the telecommunications infrastructure of billions of telecommunications users worldwide. So now that you know what we do, I want to talk about a critical challenge facing all of us. Normally, I would say this is a challenge for the open source community or the open source ecosystem, but the reality today is that software really affects all of us. It's really critical to all of our lives. And so in that context, this challenge isn't just one for the open source community, it's for the world writ large. You know, open source sort of evolved as a means of production principles on open exchange, transparency, and collaboration, what we call non-zero-sum development, where every participant wins and very few lose. For something like software which is inherently modular, today open source makes up really a giant set of Lego bricks, of building blocks that are used to create any modern technology, product, or service. Today, tens of thousands of high-quality open source components are freely mixed together to create all the technology that we leverage, whether it's driving a car, accessing our bank records, or accessing government services. Multiple studies have shown, as Amanda mentioned, that the actual code in any modern technology, product, or service, the vast majority of it, 80–90%, comes from these open source components. I mean, why would you want to write your own operating system or middleware? And so when I say that we're all in this together, whether it's a creator of technology products or services, or just a consumer trying to access their bank account, all of this truly matters. That open source is a fundamental component. I mean, even the gov.uk digital services, and I quote, is broadly clustering around Kubernetes-based architecture. There's also a substantial financial investment at stake here. Just since 2020, investors have put over $24 billion into open source related businesses across over 360 startups. These are open source specific companies that are used to monetize the open source code and then reinvest back into those open source projects that we all depend upon. For the economy, open source is a massive economic multiplier. Software developers, architects, and engineers are some of the highest paying jobs here in the UK and in the US. Nearly all those jobs require some fluency in open source. I've had doctors tell me like maybe they should switch to become software engineers. Although my daughter's orthodontist seems pretty happy with her salary, I have to say. Open source has really come a long way since my wife's initial disappointment to now being responsible for really all of the technologies that we use across the entire planet. And that success really proves one important thing, that all of us are smarter than any one of us. And that success proves that in open source, some of the fiercest competitors can come together. You know, Amazon, Microsoft, Google, these are not lightweights when it comes to competition. But every single day, tens of thousands of their employees co-develop software that we all count on. But when it comes to other major open source projects they cooperate on, this cooperation needs to bridge national boundaries as well. And in order to do that, we have to continue to foster the trust we have in these open source ecosystems. So that gets me to the main point, the state of open source today. And when it comes to the state of open source today, I quote an over-quoted British author, "It was the best of times, it was the worst of times." A rise in cybersecurity issues and growing techno-nationalism represents a two-pronged challenge to global open source collaboration. The former is an immediate threat. The latter poses a challenge to both solving security issues, but also to the long-term open collaboration that all of us count on and participate in every single day. The success of open source has attracted cyber attacks and criminal activity. We see exploitations of weaknesses in the open source supply chain used in espionage, cyber theft, cyber extortion, and in some cases, low-grade cyber warfare between nation states. The impacts of cyber attacks are real and growing more concerning by the month. The National Health Service here in the UK suffered several major cyber attacks that have interrupted and delayed care. In the US, just last week, a major hospital system in the state of Iowa had to reroute ambulances due to a cyber attack that shut down critical IT systems in hospitals. If we are to rely on software to run processes that affect whether we live or die, it is important that that software be trusted. We are already seeing the cost of the lack of trust in the rise of cyber attacks coming due. Citigroup was recently fined $400 million for failure to comply with IT security policies. Lloyd's of London has carved out exclusions, slashing coverage on state-sponsored cyber attacks. And they have suggested that other insurers should not cover retaliatory cyber operations from nation states. I should also point out, and it's very critical for everyone to understand, that cybersecurity and trust are not exclusively open source issues. Cybersecurity issues regularly arise in proprietary systems. Flaws in closed source software are equally regular attack vectors. But here's the important distinction. Open source is uniquely positioned to create trusted systems precisely because it's transparency, which in turn allows for clear accountability. Anyone can look at the source code. To paraphrase a once popular US president, with open source you can actually get trust but verify. So what can we do about this crisis? Well, at the LF, we recognized about a decade ago that we needed to understand the factors leading to open source insecurity and to create an effective and systematic approach to making open source more reliable and more secure. I want to talk a little bit about my first major introduction to this, which happened in 2014 in the wake of the Heartbleed bug. How many people here remember Heartbleed? I think most of you. It's that little lockbox in your web browser that keeps everything secure. Well, it turned out that OpenSSL, the technology behind Heartbleed, had a vulnerability in it that was exploited. And that open source package was largely being maintained by two individuals. Steve Henson here in the UK, working with Steve Marquez in the United States. Literally, the internet was secured by two guys named Steve. To deal with Heartbleed and a handful of other critical projects at the time that needed help, we raised about $6 million and launched the Core Infrastructure Initiative to go and assist these open source projects. I see Mark Cox here in the audience. He was very helpful at that time in facilitating working with the OpenSSL community that did create real improvement to their source code. But in that process of dispatching financial support, expertise to these projects, we learned a bunch of lessons. We realized that by just throwing money at the problem, it wasn't going to be enough. That we needed a comprehensive plan to deal with rebuilding trust in open source and in software writ large. So we paused. We stopped the activity, and we really stepped back to answer three simple questions before we proceeded again. What is the world's most important shared software? Who writes it? And is it being written in a secure manner? We worked with Harvard University to go and rank open source software based on several factors: the deployment and popularity of that software, and whether or not it could be used as an attack vector, that it could escalate privilege quickly, or was it network facing, was cryptography involved? And what we came up with and what we were seeking to find is literally what is the most critical software in the world in rank order by package and version number. To date, we've published two of those reports, which we call the Census 1 and Census 2, that give us this list and allow us to prioritize which open source projects we should focus on in order to collectively improve security and trust. We also, and this is critical as well, it wasn't just knowing what software was critical, it was knowing what the developers and maintainers of those software packages were thinking, what motivated them, and what they needed in the form of help. So we partnered with Harvard again to go and do another census, this time a survey, of 1,200 of the maintainers in those critical open source projects. And we asked them, what their world looked like. About 75% of them were employed. Half of them get paid to work on open source software full time. But that was really not the main motivation of the open source software developers that maintain the world's critical infrastructure. The top 3 motivations were by far non-monetary. Their motivations were to contribute to a needed fix or something that would help them get their job done. A big motivation was the enjoyment and learning that happens in open source, the sense of community. And the other thing was to be able to advance their career. The number one thing they asked for was more time from their employer, which was already paying them, to work on open source projects. Equally important, we needed to look at the root causes of open source security problems, and we realized there were many. Writing secure software generally requires some training to learn how to think like an attacker. Few software developers have this skill. How many people know in the United States the number of colleges that require a secure coding class as part of a computer science degree? So there's one, which is it? Because it's usually somebody.
UC San Diego.
UC San Diego, that's the only one. And that's probably very recent. It's just not something that people study. The very few software developers know how to distribute code in a secure way. Often software code is not signed. You don't know where it actually came from, or you're not really sure it's from who they say they were. There are no set of standards around how an open source project should secure its code, or how they should respond to security threats, or what security health they have. This is just a small sample of the challenges that we're facing. We went further and we spoke to those same maintainers again of critical software. And they said that they really wanted to participate in security and secure software development, but were under-equipped. They didn't have the training necessary. They didn't know how to decide which open source components that they were using to build the software that they used were secure or not. They didn't have a really well-maintained inventory of the software assets that they were using to create software. They didn't have access to tooling that more sophisticated organizations and their employers were using. They didn't have static analysis tools. They didn't have software bill of materials inventory. They would participate, but they needed those tools. Developers told us they wanted more training in memory-safe languages like Rust. 53% of the respondents said that training was their number 3 priority, just behind best practices implementation and tooling. Half of the developers we talked to wanted a sandbox that was similar to their employers, which were the security tools that they knew how to use and how to set up CI/CD pipelines and advanced testing. Half of these developers wanted access to security tools at discounted pricing, access to cloud services, and more. You know, there are over 780,000 developers who work every single day just on Linux Foundation projects. And I'm not even counting the millions more that work on other open source projects. We can't go fire these people. We can't tell them what to do. What we need to do is equip them with the knowledge and tools and help in order to create better trust and security. And keep in mind that some of these open source projects are made up of a single developer, often working in their spare time. And open source developers, like their proprietary peers, often focus on features over security. I mean, let me give you an example. This is just one developer who is the maintainer of one of the most widely used JavaScript libraries in the world, top 50 dependency. This is a critical project. And he says there could be security problems, but we're not patching them because nobody in our project is getting paid to do security patches or maintenance. We just say no, we can't patch that. Really, we're getting paid to add features. People only donate, and I think they were raising money through GitHub sponsors, because they want to add something new. So as we're working with all these maintainers and trying to figure out this strategy, Log4j happens. And this was another huge vulnerability that rocked us all. I think everyone is familiar with this. I'm still working with companies that continue to try and deal with the Log4j vulnerability. And when that happened, the Biden administration, the White House, called a group of us together to come to a summit at the White House, even during COVID. And this wasn't an attaboy meeting. This was, I would characterize it, and I think, Mark, you participated as well, gentle chastising, maybe the best way that I could describe it. And what was surprising to a lot of us is how sophisticated the people in the current US administration are when it comes to open source. Chris Inglis, Jen Easterly, Ann Neuberger, these are senior, Biden -2 national security officials who are deeply sophisticated in their knowledge of software supply chains. And what they wanted us to do was find ways to reduce security defects in open source, improve the process of fixing these defects, and then shorten the time it takes to distribute those fixes and implement them. Folks in the US government today are continuing to work on these problems, and I can talk later on today about all the different programs that are happening. There's a bill, a bipartisan bill in Congress today that's also going through to address some of these issues. But to be clear, the work for this was already well underway before we got called into the White House. But there was really no significant, coordinated, specific plan. We were kind of groping around the edges, right? Let's help this developer over here. Let's give these tools out, but no unified plan. And so we saw this crisis as an opportunity to establish a new modern benchmark for trustworthy software development that could exceed any form of software development to date. Working together with some of the largest technology companies in the world, directly with their CTOs, their chief security officers, their CIOs, we went to work in about a 5-month period, I guess 4-month period, to develop a plan with the Open Source Security Foundation, which is a sub-foundation of the Linux Foundation, leading that plan. And guess what? We realized in building that plan that we could dramatically improve the security baseline for all of us collectively. And our estimated price tag for this wasn't even all that much in the parlance of the benefits, about $160 million. And we can get down into the detail of the penny if you want later on, but that's roughly how much something like this we estimate costs. There are 10 goals to this plan, and I'm going to tick them off real briefly here. 1, deliver baseline secure software development education and certification to all. In 2 years, we want to provide secure software training to 1 million developers. In June, we released a Secure Software Fundamentals training course at the Linux Foundation, a free online self-paced e-learning course, and over 10,000 developers took us up on that course in the first month. We want to establish a public, vendor-neutral, objective metric-based risk assessment dashboard for the top 10,000 most critical open source projects. Is there a secure mailing list? Do they have a responsible disclosure policy? Is code review happening? Do they cryptographically sign their packages? Do they support software bill of materials metadata in that project? These things can be measured. The data is all there, but access to that data in an easy to consume way is something that's critical to our collective security. Using digital signatures across the supply chain so that we can have trust as code flows across a complicated set of distribution mechanisms. Eliminate root causes of many vulnerabilities through the replacement of non-memory safe languages. Get rid of C and use Rust. And for all of you in here who are very biased about your computing languages, forgive me saying that, but moving towards Rust, probably a good idea. Establish the OpenSSF Open Source Security Incident Response Team, number 5. You know, we're pretty good at finding bugs in software, but we're not that good at fixing them. Because You just pitch these bugs across the wall and expect open source developers who are already tired to fix them themselves. We need to bring people to them, both when a big vulnerability happens and on an ongoing basis. Accelerate the discovery, remediation, and coordinated public disclosures of new vulnerability. Number 6. 7, conduct third-party code reviews. Audit this code. Often a person who writes, for example, this speech, like me, doesn't realize that he's made a typo or that they've made a mistake. They can't think like an attacker. And so we're already underway to have paid third-party audit firms go and audit the most critical software in the world. Coordinate industry-wide data sharing that helps determine whether or not the most critical open source components have changed in their rank. Keep building that census. And then the 9th is to provide software bill of materials metadata in the most ubiquitous way possible. You see, software bill of materials metadata is only one small component that helps remediate, but if we can automate the way that software bill of material data is created, the way that it is ingested and distributed in package managers, and the way it's created in final build tools, creating essentially software bill of materials liquidity, better liquidity, we can much more rapidly address these vulnerabilities. And then finally, focus on package managers and major weaknesses in the distribution chain and build better security tools. How am I doing on time? Am I getting the hook over here? All right. The good news is this is doable. $160 million, right? Just to give you an idea, Citigroup was fined $400 million for a recent IT and security compliance weakness. The good news is we've already made tremendous progress. We have a project called Alpha Omega that's already auditing these critical open source projects. Our project SigStore is already providing a way to cryptographically sign packages in the major package managers. We're already coordinating with the major package managers to implement that. GitHub's NPM recently announced that they will be adopting this technology. We're working with government. The Department of Homeland Security in the United States created in the wake of Log4j a cyber safety review board. This is akin to the Transportation Safety Review Board that happens after airplanes crash. They examine and look at ways to improve. 9 of their 19 recommendations were based on the Open Source Security Foundation's plan. The final thing I want to leave you all with before Amanda gives me the hook here is that it's worth recognizing that we're all in this together. You know, there is a rise in techno-nationalism that moves us away from cooperation, and I think we need to talk about it and recognize it. And often it's for noble goals, digital sovereignty, privacy, and so forth. But in the words of Madeleine Albright, it's important to have a very consistent set of principles, but we can also have flexible tactics. If I had one wish for the UK government in terms of improving this situation, it's to have you not go off into the sunset on your final challenge here. But I think you and I are perfectly aligned in the one thing I wanted to get across today. Educate leaders on open source and on how software gets developed. We just did a survey of senior policy leaders in the US and UK. These are people who work for senators and the president and others. And in the US, about 64% of those leaders were familiar or somewhat familiar with open source. In the UK, it's 30%. I'd love to see that number go up. I'm open book to go and help make that happen. And that's the final thing I'd like to have all of you think about. There are tough policy challenges in the world. The economy, the war in Ukraine, climate change. But as leaders, we need to walk and chew gum at the same time. And my organization stands ready to help here in the UK, and we hope you'll join us. Thank you very much.